Hello, everyone. Welcome to our webinar, CAS IP Finder, powered by STN. In today's session, we will begin with just a few slides. We have 10 slides to introduce some of the overview and new features to IP Finder, and then we will go into a live demonstration where I will show you some of those new features. So as of this year, we have released CAS IP Finder. This is the latest evolution of STNext. For those of you that have already worked with STN and STNext, we continue to support the same content and capabilities. And for those of you that like working with the STN command line, we will continue to support those. However, what you will see today are some of the new features that we have added to enable different types of search and interactions within the platform. So indeed, what we've done here is built upon the foundation that is STN. Hence, for us, it is important to emphasize that this is powered by STN, because ultimately all of those pathways and content and search capabilities remain at the core of IP Finder. CAS is working on a variety of enhancements, and this is the first step that we have taken this year towards introducing the latest version of STN and these new features for you. So as I mentioned earlier, the command line is not going away. We certainly understand and enjoy the power and precision that comes with that command line. But now we also recognize that it's not everyone's first choice. So for those of you that prefer to work with a graphical user interface, we have some exciting new options for you. And of course, this can help for those that are beginning their journey in the IP search arena. They might find some of the new features to be an easier start to this powerful platform. Overall, we still have the key fundamentals within STN, the 100 plus databases, the curation by CAS scientists and CAS content, as well as the content from various other databases provided by groups like Clarivate and patent offices. We want to ensure that everyone has access to this data and they can access it in whichever way is most convenient for them. The main or primary new graphical user interface features that you will see are, of course, the traditional approach for the command line. We continue to support the command line, which is the search method that all STN users have been using to date. However, we've introduced new capabilities for searching within IP Finder. In the top right corner here, we have a new graphical user interface to support chemical structure searching. As you'll see, this does enable searching within our traditional structure databases, not only CAS's registry, MARPAT, and CAS React, but also the Derwent and Reaxys substance databases. We have a new point and click query builder for when you wish to search via text in various databases and searchable fields. This certainly makes it a lot easier for those that struggle with remembering field codes or database names. And we also have a new AI-enhanced exploratory search. This is using CAS's proprietary AI and machine learned models, which we have built to run a variety of our different features in not only STN in the past, but other platforms like SciFinder. You'll see with the exploratory search that you now have an easy to use method of inputting free text and then retrieving a set of both patent and non-patent literature. So you will see all of these in use today during the live demonstration portion of the webinar. The exploratory search is one that we are particularly excited about. It's one of our first steps to introducing AI or machine learning into this platform. And I emphasize it is only the first step, as there is more to come in the future. This is an AI enhanced solution. It primarily allows you to input a block of text, free text, and it optionally allows you to also include a chemical structure and limit by date. As I mentioned before, this does leverage proprietary CAS content and our algorithms. In a free text input, it automatically detects the keywords and any substances in your input and utilizes those to parse it out into points of emphasis for the search. And as you will see later, it does provide a results set of the top approximately 100 patent records and 100 non-patent records. Now, for those of you that are familiar with SciFinder, this algorithm is similar, but a little bit different from the SciFinder prior art discovery. This version in STN does indeed leverage patent full text, as well as the content from Medline. In addition to the exploratory search, you will see the point and click query builder that I mentioned previously. It is certainly a much easier to use pathway than the command line. It offers most, but not all, of the capabilities you can execute in the command line, at least at this juncture. There are, of course, development cycles ahead of us where we will ensure that this becomes even closer to the capabilities that you enjoy in the command line. But for now, we have focused on the key aspects to searching using a text-based approach, enabling you to select the database or databases from a menu of options, and then a drop-down menu for selecting searchable fields. And as you'll see a little bit later, if you are in a multi-file or multi-database environment, it will indeed show you when there are certain fields that are specific to one database or another. And as you'll see a little bit later, you do have the opportunity to add multiple rows and multiple fields and even a Boolean-based approach to indicate optionality. Now, regardless of how you search, whether it be in the query builder or the traditional command line, you have a lovely new experience to be able to view the answers within IP Finder. We call this the viewer. In the viewer, you may browse your results, again, whether they be initiated from the query builder interface or the traditional command line approach. And this nice graphical user interface gives you the opportunity to point and click to open up the results of your searching. So for those of you that are not particularly fond of display commands and display fields or formats, you might find this to be a highly preferable way of viewing the results from your searches. And as you might notice here on the slide, this does indeed include links to registries and global dossiers for patent records. And there are links to full text, of course, for the non-patent literature. And finally, a menu item to send your results to CAS SciFinder. So for those of you that do have a SciFinder account, you can certainly send your records, your results to SciFinder, or you might wish to do that for the benefit of your colleagues who prefer to work in that platform. And what you might see in the screenshots to my right here is that there will be a list view to enable you to browse your different L numbers that are generated from different search steps. And you can navigate between those and view results from older L numbers at your leisure. Moving on, We also have introduced some rather attractive visualization capabilities that leverage the analyze function within STN. IP Finder now has the ability to point and click to select different charts or visualizations, which are quite attractive for giving you insights into your current result set or any other L number in your search. This allows you to choose a variety of chart formats and different display formats for the chart. And you can select a variety of field codes and whether you wish those to be presented in ascending or descending fashion, for example. This is really nice to allow you to drill down into your results and maybe develop a deeper understanding of what you are looking at within that result set. This is, of course, a slightly different experience from those of you that may have worked with the analyze command in the past. The analyze command is certainly a very powerful feature that was in STN and it continues to be available. However, this is a much more convenient way to explore and analyze certain aspects or fields of your result set. And in this slide here, we see one example where we did a multi-file search, and we see a chart here that shows the patent countries across the globe for that given result set in CA+. And then we also see a chart where we analyzed the document types within that result set. Just a few last slides before we get to live demonstration. And a reminder that we encourage you to please type your questions into the chat box. My colleagues on the webinar will be monitoring that chat for you. Now, the release of IP Finder, powered by STN, is not just limited to the graphical user interface that I just discussed. In fact, we have also included new content in the form of new databases that you may search. So first of all, we have the CAS BioActivity Database, which is focused upon life sciences content. We have in this content collection the enriched ADME, tox, and structure activity data. So this is primarily a database that focuses on structure activity, things like IC50, for example, and showing how a ligand may inhibit a specific target. Now, almost all of this data is sourced from assays that have been published. But what we do is we curate that information and normalize it and standardize it. This includes, for example, standardizing on specific parameters and units for those parameters so that it becomes easier to compare the inhibitory effect of one ligand versus another. And this is highly precise data, allowing you to, again, compare certain activities, but then also, again, looking at things like absorption and metabolism and excretion data, as well as toxicological data. This is searchable through the command line, as well as the new Query Builder interface. Now, for those of you that are interested in this content, it is, of course, available in IP Finder through our CAS BioActivity content. There is some similar and as well unique data in our BioFinder platform as well. We do also have some additional content available for you. First of all, we have the CAS Sequences Collection. This is our most comprehensive collection of sequence data. Now, you certainly can continue to search specific sequence files, whether it be GeneSeq, USGene, PatGene, or even the registry sequence data that has chemical modifications. But we also have this nice graphical user interface with a highly comprehensive collection of sequence data that has been collected not only from CAS and NCBI, but also from patent sequence listings as well. And finally, we have the CAS Formulations Database, which is our content collection specifically focused upon formulations or compositions. These are primarily sourced from patents, wherein you'll see that they can be collected from the examples and comparative examples of a patent, as well as the claims. But we do also include a variety of non-patent sources as well. So for those of you that work in the formulations field and might be particularly interested in various combinations of ingredients into a composition, this unique content collection is certainly very powerful. And because it comes from CAS, it is indeed indexed with CAS registry numbers. And of course, there are sometimes substances or substance classes that do not have registry numbers as well. As you will see in my demonstration in just a moment, you do have different navigation capabilities now within IP Finder. On the left side of the IP Finder window, you will see different navigation options. Please pay close attention to the magnifying glass, which allows you to go to the screen that is shown here for the keyword query builder, the structure search query builder, and the exploratory AI search. If you prefer the command line, then by all means, you can click the arrow icon shown here. So with that, we will now proceed to a live demonstration where I will show you all of these features. You should now be able to see my IP Finder powered by STN. The URL is still at stn.org, stn.org. I have a setting that is currently activated that is prompting me for my transcript name. And you can see I have appropriately named my transcript according to this webinar. Now, this is the command line and session window that is traditionally visible in STN. If I navigate to the magnifying glass on the left side of my screen, you will see the query builder for keyword search, the structure search, and the exploratory search. Later, you will see the results viewer. Now, the first thing that I would like to mention is that there is a setting in your account that decides when you first log in whether it goes to this screen for the query builder or this screen for the traditional command line. And I would like to show that to you now so you may make that choice as to which home page you prefer. You'll notice that I've clicked my name in the top right-hand corner, and under the drop-down menu, I will navigate to the settings menu. So let's go to the settings menu, and you will see here a variety of settings that are available, including this new setting for the home page. So if you prefer to start on the query builder, by all means, you may select that. Or if you prefer to start on the command line because you are perhaps an experienced STN user that prefers that, then by all means, you may do so. And this setting is what we call a sticky setting. This means that whatever you choose here, it will be remembered even after you log off. Okay, so let's proceed to demonstrate some of the new features that we have here. I am in fact going to start with the exploratory search, which is our new AI-driven search capability. And what this primarily supports is an input of free text using natural language in the English language. So for example, it is very common to input claims text, or maybe text that is taken from an abstract or some other body of a document. Note that we do have a character limit of 10,000 characters, which is quite high. You will see that with my example that I now paste into this screen, that is merely 674 characters. You do have the option of selecting a date limitation. We've indicated that this is typically a priority date, as the intention behind this search is often for prior art search. But ultimately, what this is doing is pre-filtering your result set to only retrieve answers that are published prior to the date you input here. You also have the opportunity to include a structure drawing. You may draw a new structure using the CAS Draw structure editor, or you may select a structure that you have already drawn previously, such as this cobalt porphyrin structure I have here. Now, please be advised that the exploratory search does take approximately 1 minute to run. So in the interest of time today, I will go ahead and retrieve the same search which I ran just before this webinar to save some time. So let us now open that search result and view our answers from the search history. As we see here, this is now the result set for our exploratory search. So let's talk about what this did for us. The exploratory search, as the name implies, is exploratory. It's not intended to be a comprehensive search. In fact, at the moment, it is currently set where by default it will provide approximately 100 patent records and approximately 100 non-patent records. This is intentional. Now, in the future, we may entertain the possibility of adding additional answers to the result set. But the purpose behind the search is indeed to be a first pass, and it certainly should not replace your own professional skills in performing your search. This is an AI-driven search using CAS's proprietary models. It, in fact, uses a variety of models that consider quite a few aspects of the input text that I used here. So it does, first of all, break down your input text and parses it out into keywords that it then searches for within not only the basic index, such as the title, abstract, and indexing, but also things like the full text of the patent records as well. The priority date, again, was optional, as was the chemical structure. Please note that the structure search is not a substructure search in the exploratory search. It is a combination of exact and structural similarity, looking at the overall footprint of this structure and looking for similarities. For example, we might even see other cobalt compounds presented in our results. You may notice that you also have some key terms that this has been identified through the exploratory search. You do have the opportunity to select one or more of these to then rerun the exploratory search with a greater point of emphasis upon your selections. Let's minimize our search details and focus upon some of the results that we have now retrieved. I can click the title here and view some of our results. Do note that I am in the patent result set at the moment, so we are indeed viewing patent family records. I have here the initial bibliographic information, as well as the abstract and claims text. As you can see, my search did match against that claims text. We also have our indexed substances. And in this particular example, again, I emphasize the cobalt is present, but it was not a substructure search on the query we included. We also have our CAS concepts that are part of the indexing section, and these are as well considered in our search. If you find this screen to be too small for your liking, please note that you can explode or expand the viewing window, permitting you to focus on the result itself. So again, the results, the answer set, as well as the search details are all available so you can minimize or expand upon them. Let's look at a piece of non-patent literature. In our NPL, we have approximately 100 results, and similarly, we can point and click to see those that were retrieved by the exploratory search. Again, this works in a very similar fashion to the search that retrieved our patent results, with the exception that this is not currently looking at the full text. But we again do see that bibliographic information with our hit highlighting. We have our indexed concepts and our indexed substances. Take note that currently we are sorting results by relevancy. We will introduce additional options for sorting in the future. Of course, a relevancy-based sort does seem to make the most sense when you are using an AI-based retrieval. I would like to address a topic that often comes up when it comes to AI-based approaches. We do, of course, take your data privacy to with all seriousness, and we have posted online our own policies around data privacy and AI. Of course, if you have any questions, you are welcome to contact us or speak to your CAS representative. But in short, we do not use your data, nor do we share it with any other parties. We do not use your queries or share your queries with other parties. What you search is private to you. And it is also worth mentioning at this time the roadmap for future AI capabilities within IP Finder. We are looking forward to a future state this year where we will be introducing an agentic feature that is more of a LLM or chatbot type interaction that will be available to you. And that agentic feature will allow not only searching, but you should be able to even consult with it to understand the capabilities within STN and receive guidance on how to search STN. That is the current vision. So, of course, we will keep you updated as that comes to fruition later this year. Very good. Now, you may have noticed from my exploratory search that there is this button here that says Send to Command Line. We can select this if we want to take our results from the patent and non-patent literature and take them to the command line to do some additional manual searching, or maybe you might even want to combine this with some other search strategies for a more robust search history. You'll notice that currently this is going to search in the CA Plus database. For those of you that are operating under a transactional plan, we do have it on the roadmap quite soon to add H and Z CA Plus options as well for more cost-effective searching for our friends on the transactional plan. You will notice that it takes the accession number from the records that I have here. So these 196 records should be taken and then searched according to accession number in the CA Plus database. And beyond the exploratory search, what we will also talk about today is the query builder, which may be used for keyword-based searching as well as structure-based searching. So please bear with me a moment here. Let's go ahead to our structure window in the query builder. I think this is a particularly nice feature insofar as it retains all of the structure capabilities that you have enjoyed thus far, but it does alleviate a couple small aspects around the command line searching. Of course, you can draw a new structure using the CAS structure editor, or of course, importing from your preferred structure drawing platforms. For the interest of time, I will go ahead and select a structure that I have already drawn previously. And this is quite a nice pop-up window here to prompt you to select the structure database of your choosing. So we have, of course, not only the CAS databases of CAS, React, MARPAT, and Registry, but we do have Elsevier's Reaxys content, as well as Clarivate's Derwent chemistry resource and Derwent Marcouche resource. Let's navigate into Registry. And what we will see now is that it will upload my structure. And I would like to draw your attention, please, to these menus on the right side, wherein we can see our option to choose the structure search type, exact, family, closed substructure, or substructure. Naturally, substructure is the most common that most people use. And you have the opportunity to choose whether to do a sample search or a full search. Now, the sample search is a practice that we continue to educate and encourage you to use so that you may retrieve a sample and check that your query will work within the system limitations. Of course, with our expanded iteration limit, it is very difficult to break it with something too broad. But the sample search, of course, is a free search for those of you that are on the transactional plan. I will jump right into a full search here. And at the bottom of the screen, you can see the command line preview, which is showing us that it will go to File Registry and then subsequently perform a full substructure search. Let us go ahead and initiate that search. And you will now see the results viewer. The results viewer at a glance might look similar to our exploratory search in terms of the windows and the shading, but this is in fact a slightly different viewer insofar as it is displaying for us our results from any searching we do in the structure drawing tool or in the query builder, or we can even send results to this viewer from command line searching. You can see here that I have 462 substances that matched my structure. I did a substructure search, so it's no surprise that we see blue highlighting for my query as well as black for our additional substituents. And you can see some additional results here. These are currently sorted by registry number in descending, meaning answer number 1 is the most recent, and then the answers at 462 would be the oldest. Of course, everything you see here in blue is interactive, allowing us to observe more about that substance record in registry. Now, this is a more recent substance that I've selected here, so maybe there is some limited information available, but you would be able to see not only the registry number and structure, but also molecular formula, substance class, and quite nicely, the ring system data. The ring system fields are rather underutilized, but highly powerful fields that you have at your disposal, particularly useful for searching coordination compounds and organometallics. Do note that when viewing any records in the viewer, whether that be in registry or any other database, You can indeed view additional fields. I find this to be a very convenient function to allow you to explore any additional data for that record. And again, it alleviates the need for you to memorize any sort of display fields or formats. I will show this to you again in a little bit, where you could see this for a document record as well. Very good. Now, please do note that on the left side of the screen, we see our L numbers, L1 being our uploaded structure, L2 being my full substructure search. In addition, we have the opportunity to now perform additional filtering. Do keep in mind that we are currently in the registry substance database, so any additional filtering will be on our substances. We can select this button here that shows Edit Search. When we choose this button to edit search, this is our opportunity to filter within this graphical user interface. I can add a field, and I can choose any of the searchable fields presented here within the registry database. So for example, I might prefer to search on the element symbol, which is a way of indicating elements that may or may not be present in my substance. And in this instance, I might be interested in iridium, so I may search iridium's element symbol. Clicking search, this is now doing a filtering step where it has taken L2 and IR/ELS, iridium in the element symbol field code. So this is a narrowing step by applying the AND Boolean operator. We have narrowed our search from 462 to 27 substances. And from here, naturally, you might be interested in going to retrieve additional documents. Before I do that, please do note that there is also this option here to take your substance set into SciFinder. Let's go ahead and get some documents for our 27 substances. When we choose Get Related Documents, it gives us this pop-up window. We can elect to choose all of the documents, or we can elect to choose specifically patent or non-patent literature. Before I proceed, I would like to also mention something else of import, which is I'm about to retrieve documents for all 27 substances, but if you prefer, you may select specific substances and then proceed with getting the documents only for your selected substances. This is, of course, quite convenient, as those of us who have worked with crossover steps in the command line might recognize that it can sometimes be quite challenging to choose specific substances of interest for your crossover step. Let's go ahead and get documents for all of our results. This is now performing the crossover step, where I'm going to navigate to CA+ to get the documents for my 27 substances. So we've gone now from 27 CAS registry numbers to 260 records within CA+. And I do have here a mixture of patent and non-patent literature, as shown here, where it shows patent published in 2025 and journal published in 2025. As you can see, it is showing for us one hit structure. Obviously, there's one particular structure that's quite popular, and here's one of a little bit of variety. Let's open up one of these, and I will choose to minimize my search history on the left. We again have our bibliographic information. We have our patent family table and priority information, classifications, patent pack, as well as our hit structure from our previous structure search. And as I mentioned previously, you do have the opportunity to view these additional fields, which in this case, because it is a document record, is showing us our supplementary terms, our CAS indexing terms, as well as registry numbers and claims text as well. Do keep in mind that if you wanted to search on something like claims text, that is also available within the edit search function. Of course, when you search on claims text, you are inherently omitting journal literature. Let's take a look at the visualize results. Visualize results allows us to generate charts on the fly. I like to use the custom charts. Let's go ahead and click this button here. It allows us to choose what chart type we want to use. I'm particularly fond of the stacked vertical. And we can choose which fields we want to use for analysis and charting. So a simple example might be publication year, and comparing that to something like an assignee or maybe even a country to see where are the patents coming from. We click continue, and this is running an analyze command in the background, so it might take a moment to generate. Of course, the amount of time that takes is largely contingent on the size of your result set and which data fields you choose. As you can see with this example, this has now provided me a timeline according to publication year, and it is then charting for me the patent countries for each of those given years. Note that you do have download options for your charts, allowing you to download the data itself or indeed just the image. And you may have noticed that you also have the opportunity to add additional charts at your convenience. So for example, I might want a pie chart that looks at assignee names or something similar. I'm about to move on from here and talk about the text-based query builder. But maybe just look at one last results here. As I mentioned previously, you do have the patent pack links available to you, as well as full text, the register, and global dossier, as well as prior art analysis. We'll look at that a little later. Our interactive patent pack PDF is, of course, a beloved feature in IP Finder. This allows us to view the full text, but it also allows us to navigate to the exact location of substances within the full text, regardless of the language or format of disclosure. So we certainly wanted to ensure that you had access to those patent pack links through this results viewer. Now we will move on and take a look at the query builder. Please note that I am keeping an eye on the chat, as are my colleagues, and we do encourage you to type in your chat questions at your convenience. No need to wait for the end. Let's go back to our query builder. So we've talked about the exploratory search, which is the AI search that generates up to 200 answers. We've talked about using the structure search, and now we can look at the keyword search capabilities. This is a very nice interface to allow you to perform text-based searching using a variety of databases and field codes. In this example, I can choose one or more databases. So for example, I might want the CA+ bibliographic database, and maybe I'm interested in looking at full text patents from WIPO. I can choose specific fields. You'll notice that as I access this menu, it is telling me which fields are specific to certain databases, as I did choose two. Those that lack the yellow bubble are available in both databases. I want to do a claims search, and so I choose the claims field, and you'll notice that it has now selected that in my menu, and I can type in my keyword-based search. Electrochemical reduction. Currently, it is best to put parentheses around your terms if there's more than one term to aid it to apply the field code to both of those terms. As you can see here, because I'm doing claims text searching, it is automatically added the CLM field. But let's say you wanted to add more to your search. Maybe you wanted to alternatively look at patent classifications like the IPC code. We can do that and choose IPC, where I can type my C25B IPC. And I would actually like to treat this in the alternative to my claims text. And so I will be adding the OR operator. And as you can see at the bottom of the screen, our command line preview is showing us we'll search electrochemical reduction in the claims text or C25B in the IPC field code. This is the sort of search that you've always been able to do in the STN command line, but now it's just so much easier working with the query builder. Let's add one more field here where I also want to search for ion exchange. You can introduce wildcards if you wish. In this instance, I'll keep it in the basic index. Now, you'll notice that by default, it is selected OR because I have the OR Boolean on my previous line. What if I wanted to search for electrochemical reduction or my IPC code, but the basic index search of ion exchange must be present? In this case, we simply group together our searches and we say that indeed we want to search for electrochemical reduction in the claims or C25B in the IPC, and there must be ion exchange in our basic index. And you can now see that it has done the appropriate parentheses stacking to indicate this grouping that I have selected. Naturally, you have a variety of databases and field codes to work with, so I certainly do encourage you to explore at your convenience and give this a go. Let's click search, and this will now take us back to our results viewer. Notice that our results viewer is still showing us in our history on the left the very same L numbers that we searched previously. But now we do see the search for our various databases with 4,000 or so in CA+, 3,000 in PCT full, and then the total 7,500. We can navigate back and forth between those two files. For now, I will focus on CA+, as it is the combination of patent and non-patent literature. As before, you of course can click any of these to view more details about that record. Again, no need to type in the display command. And as before, you can edit your search to add additional fields, such as a patent assignee search, where I might say I want to look for Liverpool University. This will automatically apply the S proximity operator, which will allow for either term to appear first, searching in the assignee field. This will, of course, come down to a much narrower result set. So we have here our search for the University of Liverpool from our assignee search. And we see some of our keyword terms that we searched previously, ion exchange, and some of our matching IPC codes. And finally, do remember we have the view additional fields. It's kind of hidden at the bottom there. We get that pop-up window, which again shows hit highlighting for our basic index search. And I don't see any hit highlighting. There we go. Claim 16, my claims text search. So all three matched in this result. Very good. Now, we talked about the AI search of the exploratory search previously, but please do keep in mind that you do indeed have the prior art analysis. So where the exploratory search is focused on a free text input with the possibility of adding a chemical structure, this prior art analysis is intended to be started from a patent record. So you certainly could have stumbled upon a patent record as I did here, or maybe you simply started with a patent number search. And then you can choose this menu and you can opt to view your answers either in the command line or the nifty new IP Finder viewer. Again, this can take up to a minute to run. So as I am on my home internet and doing this via webinar, I hope that it does not take too long for you. While we wait for this, I would like to address a question in the chat from my multi-file search in CA Plus and PCT full. The question in the chat was, how do you identify duplicates? Now, currently in the results viewer, there is not a built-in feature for duplicate removal or duplicate identification that I'm aware of. I invite my colleagues to correct me if I'm mistaken. However, if you would like to, you can take those duplicates or that search and send them to the command line where you can perform that duplicate identify or duplicate remove step. And then naturally, from there, you can continue to work in the session window using command line, or you can take those deduplicated results back into the viewer. So we have ensured that you have the flexibility to go back and forth between command line and the results viewer at your convenience. And certainly we will make note that a duplicate remove is a feature we would like to add as an easy feature to the results viewer in the future. Do keep in mind that we're on the first step of this journey and there's more to come. Now, while I was speaking, you may have noticed that my prior art analysis did complete. Of course, it's initiated from one patent record, so you simply see that patent record in the search details on the left. And now we see that that did generate a combination of patent and non-patent literature based off of the patent record that I started with. So the results set may seem similar to what you saw with the exploratory search. However, the overall workflow is different insofar as the prior art analysis is initiated from a single patent record. Naturally, again, this is not intended to replace a comprehensive or precise search driven by your own human intellect, but it is a very convenient first pass and oftentimes a great start to finding highly relevant prior art. Please keep the questions coming. With our last few minutes, we will just address some of the final additions to IP Finder beyond what I've shown you today with these graphical user interface options. In addition to what I've shown you with the exploratory search, the structure search, the keyword search, and the results viewer, we talked about the prior art analysis, but we also have those new databases that I shared with you previously. You have new sequence content available through CAS Sequences, available from the My Files drop-down menu, as well as this double helix icon on the left. And you have new databases in the form of CAS Formulations, as well as CAS BioActivity. Now, in the interest of time, we're going to do just a very brief search in CAS BioActivity using the command line. I'm navigating to, there we go, file CAS BioActivity. I like to abbreviate this to CAS Bio. You'll notice that I have now entered the CAS BioActivity file as indicated by the welcome message and the icon at the top, as well as my history tab on the right. Now, CAS BioActivity does have a variety of searchable fields as shown in the help message that I called up here. It is particularly useful for understanding structure activity data between ligand and target. But we do have tox information, ADME information as well, and you might be interested to explore the expandable fields for parameters, SAR parameters, as well as ADME and tox parameters. Briefly, let's go ahead and use the SAR reference locator field to pull up all of the activity information in this accession number that I've input here. That did give us 701 records in CAS BioActivity. So what this has done for us is given us the 701 records for that single document showing the activity data in that document. I'll do the default display format for one answer here. Oops, let me try that again. And apologies, maybe if I do a different display format. There we go. Sorry about that. I have my SAR prop display format. This is the SAR property information. And what we see is that this is a ligand-based entry here where we see our ligand identified by registry number. And in the accession number that I searched, which is this CA plus accession number representing this, this WIPO patent record, we see the reported data from the assay in that patent record. It is denoting the targets that were described in that patent, the inhibitory function of our ligand, the parameter, in this case Ki, and then the values that were provided. So in this instance, the patent record reported this in nanomolar, and we at CAS have normalized this to micromolar. As you can see, there are closed ranges and open ranges as well. The assay buttons on the right are indeed interactive, where you can learn more about the assay details that were provided in that original patent record, including the procedure, the disease or cell lines if provided, and again, the values and parameters. So for those of you that do work particularly in pharma or medicinal chemistry, it is particularly a very powerful database. But even, I'll say, working in prior art search, my colleagues and I on the call have spent a lot of time doing prior art searching. You sometimes get that claims text that's focusing on a certain kinase inhibitor. It is very powerful to be able to perform a search on an SAR target name and see which ligands have reported activity below a certain threshold for that target. Now, with that, we have covered all of the content that I intended to show you today for CAS IP Finder. I would like to emphasize, based on the questions on the chat, that STNext with the command line and all of the searchable field codes, databases, and capabilities that you know and love, those are continuing to be supported. Nothing that you have been doing in STNext will go away. We have simply added additional new features for your benefit in these query builders and results viewers, and we now have the ability to build upon this fantastic foundation to add exciting new features for the future. So please do stay tuned this year as we add even more, and it certainly is going to be an exciting journey.